Hello everyone, welcome back. Today's topic is tangents and intersecting chords. Now, many of you might be thinking that this topic is really very difficult. So if so, then this is video for you only. Okay, watch this video till end. We are going to discuss so many things, starting with the theorems, and then we are going to solve many questions based on those theorems. So connect with me till end. All right. Now here some basic ideas. Okay. So when a circle and a line are given, so there can be some different positions. Okay. So the first one is the line is not intersecting or not meeting with the circle. So that is the first scenario. Now, when the line intersecting the circle, so it will intersect with two different points, and that time this line is called the secant of the circle. Okay, it is called the secant. And third position, the line touches the circle. When the line touches the circle, it is point of contact is only one. Okay, this is one and only one point where it touched, and this line is called now tangent. Alright, so you are aware of this. So now let's move on with the first theorem. So now what it is saying, the tangent at any point of a circle and the radius through this point are perpendicular to each other. Means what? We are given this circle, AB is the tangent, P is the point of contact, O is the center, and we have to prove that OP is perpendicular to AB. Now we'll write the proof. Okay. So now the first thing, okay, what I can say here, Q is any other point except P, okay, which is on tangent AB. Now what I can say, OP is less than OQ. Can I say that? Why? Because Q is outside of the circle, okay, Q is not in the interior part, Q is in the exterior part of the circle, okay. Of the circle. Now what I can say, any point, okay, I can prove that any other point, okay, which is here on the tangent, that is exterior on the circle, there is no other point which is interior, and I cannot make the tangent that way. All right, so OP is the shortest distance, that way OP is the shortest distance, and we know that the shortest distance is always perpendicular for the, it is a perpendicular only. So I can say that OP is perpendicular to AB with the reason that the shortest line segment, it is a perpendicular to a line only, a perpendicular to the given line. All right, so here we can prove that OP is perpendicular to AB, means the radius is perpendicular to the tangent. Okay, now what I can say for this theorem, okay, now from this theorem we can prove some more important results which are really useful to solve some questions. All right, now that is called the corollary. So what it says, the first thing first, okay, so the tangents are equal in length. So here the point P is here, which is exterior point, and I am drawing the tangent AP and PB. Okay, so these tangents are in equal length. This we have to prove. The tangents subtend equal angles at the center of the circle. So here angle AOP equals to angle BOP. These two angles are equal, that we have to prove. And the tangent are equally inclined to the, means what, these angles are also equal, that we have to prove. Okay, these three things we can prove. Now it is very easy to prove. Okay, so what I can say, to prove this I can use the congruency of two triangles. Now check here, see, this are radii, so what I can say, OA is equals to OB. Why? Because they are radii. Okay, Then what about this angle and this angle? Yes, they are 90 degrees. So angle OAP equals to angle OBP because they are right angles. Why they are right angles? Because OA is perpendicular to AP and OB is perpendicular to OB. We just proved that. Okay, the theorem. And now, which line segment is common? Yes, OP is common in both of them. So what I can say, triangle OAP is congruent to which triangle? Yes, OBP, right? By which criteria? RHS criteria. Correct. And hence what I can say, by CPCT, these three things can be proved. Yes. So you can simply write that. Hence by CPCT, PA equals to PB, angle AOP equals to angle BOP and angle APO equals to angle BPO. And hence proved. Alright. Okay. Now one more theorem. Okay. So what it is saying, when the given two circles touches, okay, the circles are touches. Now here there are two cases. Okay, the first thing, the circles touches each other in, I mean externally. Okay, they touch externally. Now the given things is A and B are centers of the circles which are given. All right. Now and they touch at the point P. Now what I can do, I can draw a tangent PQ, okay, which is from point P. Okay, so I have drawn that. Okay, and we have to show that point P is lies on line AB. All right then. So what I can say about this angle? Tell me. Yes. So angle APQ is equals to 90 degree. Correct. Why? Because we just prove that AP is perpendicular to PQ. PQ is a tangent. Okay, one more thing what I can say about this angle. So angle BPQ is equals to 90 again. Why? Because BP is perpendicular to, yes, PQ. Correct. And now what can I say about these two angles? Angle when I add them, correct. Now you are, I mean, you know this, right? BPQ is equals to 90 plus 90, which is 180, correct? And hence, what I can say, this angle APB, angle APB is equals to 180, means it is a straight angle. So, this is a straight angle. So, we can say that P is on line AB, correct? P lies on line AB, correct? Hence, we prove this. Now, we'll take the second case, okay? When the circles touches internally. What I can say? Again, can I say this angle? Which angle? Now, which angle do I talk about? Angle. See, we joined the tangent only, okay? We just constructed the tangent. And now I am writing the proof. So, angle QPB. How much is it? Tell me. 90 degree. Why? Because the same reason of theorem 1, what it is? BP is perpendicular to tangent PQ, correct? Same way, what I can say about this angle APB, they are same only, right? But yeah, I have to write this. APB is equals APQ is equals to 90, correct? Why? Because AP is perpendicular to the tangent, right? So they both are same angle. They both are same angle. So APQ and angle QPB are same. at same angle. Correct. So what I can say, P is on line AP. Hence we prove this. Correct. Great. Intersect internally or externally, then the product of their lengths of the segment is equal. Alright. Now how to prove this theorem? So let's understand. Now the first case. Okay. Here the chords AB and CD, they intersect internally. Okay. They intersect internally. Alright. And we have to prove that. See what we have to prove. This AP into PB is equals to CP into PD. Alright. This we have to prove. Now what to do with this? So what we'll do? We'll join AC and BD. Okay. We'll join AC and BD. Now can you see two triangles? We learned similarity. So can we prove these two triangles are similar? Yes, we can. Let's check how. So proof, what I can say, in triangle. Okay, I'm saying in triangle APC, and which other triangle I am taking? BPD. Okay. Now what can I say for these two angles? Yes, they are vertically opposite angles. So angle APC equals to angle BPD. Why? Because vertical angles. Correct. Opposite angles. Alright. Now what can I say about this angle and this angle? Right. So angle, tell me, do you remember the trick circles? Okay. See, if I think about this arc BC, this is the face of a cat and these are the ears. Remember? So angles in the same segment. Yes, now you remember it. Correct? So what I can say? Tell me. Angle, which angle? CAP equals angle BDP. Correct? Angles in the same segment. Don't write the ears of the cat, okay? Angles in the same segment. Alright. Now, tell me. If the ears, can you see them? Yes. So, what I can say? Angle PCA is less than angle PBD. Correct? PBD. Why? Because, again, same reason. Angles in the same segment. With the, this is the arc. Okay, here the arc is BC and the for the second one arc is AD. Okay, I am mentioning it. So same segment and the arc is AD. Alright. So which criteria now? So now which criteria? Let's write the criteria. Which triangle? Triangle APC similar to. Now with A. Okay, A and D are same. So angle triangle D. Correct. With P it is P and with C it is B. So this is a similarity. A. Right? Criteria. So what I can say now, which ratio I am interested with, AP or PA upon here DP. So I'll take that PD equals, now I want PC. So I'll write PC and I'll write, now with PC it is PB. Correct? And now by cross multiplying this, what I can say, PA to PB equals PC into PD. Hence, we proved it. Correct? Alright. Now, let's talk about the second case. When this chords, Okay, these chords intersect externally. So P is the external point. Now we are joining this, okay, and you can see the figure like this. Now we have to again prove the same result, okay. AP, see, AP this whole into PB equals to PC into PD. Okay, we have to prove the same result. Now what we'll do, we'll again join this AC and BD. Now what can you say about this quadrilateral ABDC? So what I can say, quadrilateral ABDC is a cyclic quadrilateral. Yes, is a cyclic quadrilateral. And now what I can say about this angle and this angle, in circles we learned this, right? Yes, you are right. So angle, what I can say, angle B, angle PDB, okay, PDB is equals to angle, which angle I am talking about, PAC. See, which two triangles I am talking about, let me write here. Triangle PBD I am talking about here, okay, PBD, and triangle PAC I am talking about, okay. So I am saying in this triangles, these two angles are congruent. Which other two angles I can say congruent? This is also external angle and this is the opposite interior angle. So angle PBD equals which angle? ACD, correct? Here we have to write that external angle of cyclic quadrilateral is equal to the opposite interior angle. Opposite interior angle. Alright, same result for the second one also. Okay, now using AA criteria, tell me which is the similarity. Triangle PBD is similar to, now with P it is P only because they are common. Now here when I talk about B, then it is C, and when I talk about D, then it is A, right? So this is the similarity, AA postulate, correct? And then what I can say now, take the ratios. I am interested in PB to PC equals, now I am interested in PD, so PD and PA. And now on cross multiplying them, what do we get? PA into PB equals PC into PD. Hence we proved it. Great. Alright. Okay. One more theorem. Alright. What it says. Now the circle is given and the tangent is given. Okay. So we have to prove that. See. The circle with center O is given and the tangent PQ is here. Okay, it touches the circle at point A, so P is the point of contact. And now, what I have to prove? The angle between the tangent PQ. Okay, tangent PQ and the chord AB. Where is the chord AB? This. So, this angle. Okay, this angle. This angle through the, okay. And the angle in the alternate segment. So, we have to prove that BAQ is equals to ACB. This angle. These two are same. Also, one more angle I can see here. See, let me just highlight with this blue color, with this blue color angle. Okay, and one more I can say this green color angle here and this green color angle. Okay, this I have to prove they are equal. Okay, so what we have to do? So first of all, we have taken the construction. Okay, the construction is diameter AR, okay, which is passing from the center O, and now we have joined this. Okay, we have joined this RB. Now what can we do for this? How we can solve it? So in triangle ABR, what I can say, triangle ABR. Now see, remember the diameter and the angle subtended with by the diameter on a segment. How much is it? Yes. So angle ABR equals 90 degree. Correct. Angle of semicircle I can say. Alright. Now what else? This angle. Okay, this angle plus this angle. How much is it? They are complementary. So they are sum up to 90 degrees. So angle BRA plus angle BAR equals 90. Right? Okay. We'll take this as result 1. Alright. Now what I can say about angle, this angle, what I can say, angle OAQ is 90 degree. Correct? Why? Yes, because the radius is perpendicular to OA is perpendicular to the tangent PQ. Sorry, PQ. Alright. Okay. Now from this, okay, here which two angles are there? Tell me. Angle BAR plus angle DAQ. BAQ, right? Angle BAQ equals 90 degree from this. So from result 1 and 2, what I can say, from 1 and 2, what we can conclude? Tell me. See, BAR is common in both. So what can I say? BRA equals to BAQ. Correct? What I can conclude? Angle BAQ equals to angle BRA. Okay. Now if I talk about this chord, okay, this arc AB, cat face, and ears, 2 ears. Which are 2 ears? Right. So what I can say, angle BRA and angle BCA, segment angles in the same segments. So can I say this equals to angle BCA or ABC? Yes. These two angles are angles in the same segment. Correct? Okay, and now we already proved our first result. So what I can say, angle BAQ is same as angle ACB. Hence we proved the first result. Okay, the first result is proved. Now let's come back here. Now we have to prove angle BAP. BAP equals to angle ADB. Okay, so what I can say now, BAP plus BAQ 180, right? So I'll write this, angle BAP plus angle BAQ equals 180. Okay, straight line angles, correct? Angles on line PQ. Okay, now one more. What I can say, angle ACB, and angle BDA, correct? Are they 180 degree? Why? Because opposite angles of a cyclic quadrilateral. Can I say that? Yes, I can. So angle ACB plus angle ADB equals to 180. Opposite angles of a cyclic quadrilateral. Correct? Opposite angles of a cyclic quadrilateral. And then what I can say now, see, we already proved that BAQ equals to ACB. These two are same. So yes, slotted, right? Angle BAP equals to angle ADB. Correct? BAP is equals to, see what we have to prove. BAP equals to ADB only. Correct? So we are done with this. Correct? Perfect. Now one more theorem. Okay. So this is the last theorem and this is super easy. Okay. See, understand. Don't afraid with the lengthy statement. This chord is given, which chord? AB, and tangent PT. Okay. These two are given. They intersect externally at point where P. Okay. That is given to us. And now we have to prove that what this PA to PB, PA into PB is equals to PT square. Alright. So now what we'll do, we'll just join this A and T. Okay. We join this A and T. This is a construction which we have to take. And also we have to join T and B. Alright. Okay. Now prove. So if I talk about this whole triangle, big triangle, which big triangle? Triangle PTA. Okay. And the small triangle which is created here, this angle, triangle. So this triangle PTB. Okay. Which angle is common? Correct. Angle P is common. I am trying to prove they both are similar triangles. Okay. So P is common. Now see, the hint is whenever this type of just think about the ratio. Okay. If I'll prove that PA upon PT is equals to PT to PB, then this is done for me, right? So I'm trying to prove that by using the similarity. Okay. Now which other angle I can say? Just now we learned that this angle. Okay. This angle is equals to this angle just now in the previous theorem. So I'll use that. Okay. Use the same result. So angle PTB, angle here. Okay. PAT for this. PAT, big triangle I am writing first. So PAT is same as angle PTB. So now using the AA postulate. Okay. Using AA postulate. Which two triangles are similar? Let's conclude that triangle. If I take PTA, then along with P it is P, along with A it was T, right? So A it was T, then T it was B, like this. And now I'll write that I'm interested in PA. So I'll write PA. Here it is PT. And I'm interested in PT. So I'll write PB. Correct? Understood this one? So now by cross multiplying this, what I can say, PA into PB equals PT square. We are done with this. Correct? Great. I hope you understood this, right? Okay. Now, in the second part of this video, I am coming with the questions which we are solving based on these theorems which we learned today. Okay. So, thank you for watching this part and watch the next part for more understanding. Alright.